Alright guys, today I'm going to go over Firestarter 13 and Firestarter 14. The biggest concept today is going to be talking about these two these ideas. So one of the main ideas we're going to talk about today is we're going to talk about these properties right here. So these properties right here, these radical properties, this is going to be one of our biggest concepts, and we don't actually aren't going to show these steps a lot, to be honest. We're going to usually not show all this math behind it, but you do have to realize that if there's a multiplication symbol inside the radical, you can split it into two separate radicals as long as they stay inside the radical. So remember, I call it a jail. So if you have a times b inside the jail, you can split into two separate jails as long as it stays multiplication in between and they stay in jail. It can also work both ways, where I could take my two jails and I can turn it into one jail as long as it's all multiplication. Right? So sometimes it'll be convenient to do one thing, sometimes it'll be convenient to do the other. Same thing happens with division, right? So that's a division symbol right there, or a fraction, right? So sometimes you could take the radical to the top and the bottom of the fraction. And like I said, sometimes it might be more convenient to take those two fractions, two separate radicals, and put it into one radical. So it works both ways. The other super huge idea that we're going to talk about today is we're going to talk about conjugates. All right, conjugates are what make the radicals disappear in the bottom of a fraction. All right, we're going to spend a little bit of time explaining conjugates. So there are two rules when it comes to fractions. The first rule is you cannot have a number on this list. You can't have a number on this list that divides by the number inside the radical. That's what we did yesterday, where we were looking for perfect numbers and made them change. The other rule is you can't have a radical in the bottom. So you use conjugates to make that go away, and we use this concept of multiplying by 1. Right? This is a huge concept. Right? We always multiply by 1 because 1 does not change anything, it just makes it look different. Right? So that's what we're going to go over. Alright, so once again, I told you to try not to use a calculator because it's just much easier for you to break down radicals if you know perfect squares. It's not impossible. So I'm just writing these down as fast as I can. And the idea is that I don't have to think about them. I'm not using my calculator. They're in my brain already. Now that you might not know that, which is fine, but if you practice it a lot more with it, it's going to make your life a little bit easier. So, and I messed up on 19 squared. I just realized that that should actually be 361. I don't know what I was thinking. I actually messed up on 19 squared, and another time I wrote the wrong number down. I think I wrote 381 down on one of the pictures, so you have to check that out. So sometimes because I'm just doing it really fast, I get some numbers mixed up when I'm writing really fast, and that happens. So I'm going to use these numbers to see how things work. Alright, so there are the numbers in order. I'm going to do these. I'm going to do the bottom three first because they're a little bit easier. So remember, we talked about these already in class. Either if you were A group, we talked about this one in class, or the other one we talked about in class. So 338, alright, 338 is not perfect, right? So not perfect. Alright, so since it's not perfect, I have to find a number that goes into 338 evenly. Remember guys, I always start from the bottom of my list, and I really only care about the numbers that are on this list. So I only care about perfect squares. I do not care about all these other numbers. So I want to find a number that goes into 338. So 338 would be right here. I just keep on dividing, and I do my calculator. 338 divided by 321, decimal. Decimal, 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 not a decimal. So this is 2 times 169. Right? Now, 169 is perfect. He's going to be able to leave jail. So remember, I call this a jail. 2, he is a murderer. So he's never going to leave jail. So I have the square root of 2 times 169. I usually don't write this out, but this is my product property and stuff like that. So usually I do it just like this. I say 169, he is going to change. He's going to change into 13 squared. Now to leave jail, he literally has to change. He has to give up that little 2 to leave jail. So 169 turns into 13. 2, he stays in jail forever. We're done. Now I know I'm done because this 2, there's nothing on this list over here that 2 can go into evenly, so that's how I know I'm done. The next one, 192. 192, not on the list. Right? 192, not on the list. So I start finding a number that goes into 192. 169 doesn't, 144 doesn't, 121 doesn't, 100 doesn't, 81 doesn't, 64 does. So 64 times 3 is 192. Remember, you always want to start at the bottom of your list because then it's much more likely I only have to do this one time. And I'm going to show in a second what would happen if you don't start at the bottom of your list. But I highly recommend starting at the bottom of your list. Remember, 64 is perfect. He has to change. So he must change to leave jail. So he changes into the square root of 64 is 8. All right. 3, he is not going to change. He's going to be in jail forever. Boom. That's it. Now, if you don't listen to me, you might find out that 192, and you don't have to write this down, but you might find out the square root of 192 can be written differently. Like 4 also goes into 192. Right? And then 4 would be your perfect number, and 4 is going to change into 2. And then 48's in jail. Now this isn't done. This is not wrong. This would be kind of like if I went, hey, simplify 10 over 20, and then you wrote down 5 halves, or 5 over 10, instead of writing 1 half. That's kind of like what's going on here, as I didn't simplify it enough. And the reason I didn't simplify enough is because, look, 48 can still be divided by 4 again. So now it's 4 and 12. So this 4 is going to turn, so now I end up with 2 times 2 radical 12. And I'm going to actually have to do it a whole another time after that. So this is why I want you to start at the bottom of your list and work your way up. So try to do that. So remember, that is too much work. Alright? Too much work. So now we're going to go on to the last one. The last one, square root of 225. Well, 225 is perfect. So the square root of 225 is the same thing as 15 squared. Remember, the little 2 and the check mark cancel, so it is just 15. The most common mistake I see is somebody tries to add this. Don't add the radical, right? The radical is gone. Because 225 is perfect and he changed, he doesn't get to stay in jail. Now, one thing we will talk about a little bit later is because 15 squared equals 225, and at the same time, negative 15 squared equals 225. This could be plus or minus, and we'll talk a lot more about that next week. Alright, so first thing I'm going to do with number 2, this is where we deal with radicals. So there are 2 rules. Rule number 1, so we have 2 rules we got to worry about. 2 rules. No perfect square factors. That's a rule. All right. The other rule, no radicals in denominator. So I'm going to start with the second one first because it's a little bit easier. Now, I don't want to deal with a fraction, so the first thing I do is I take the radical to the top and the radical to the bottom. If radical 2 was not there. If this radical was not there, we would be done. But it is. So this one is done. That there are no perfect square factors. There's not a perfect number that goes into 5. There's not a perfect number that goes into 2. The only reason we have to do any work is because we're not have a radical on the bottom. That's when we use conjugates. So conjugates always, and I call it a conjugate box. You're always going to multiply by something. So that's how you change it. You make it look different by multiplication. Whatever's in that box has to equal 1. That's the rule. So what I do is I figure out, is this an easy conjugate or a hard conjugate? This is easy since no plus or minus. So this is an easy conjugate. We're going to look right here. So a conjugate's a pair. It says if you have a radical, I just am going to choose to multiply by the exact same radical. So I took this and I made it match. I chose it. I could have wrote whatever I wanted on the bottom here. I'm allowed to write whatever I want as long as the top and bottom match. So since top and bottom match, it's equal to 1. 1 times anything is anything. So this doesn't change anything. So now I'm going to multiply. Both these guys are in jail, so I can do radical 10. Both these guys are in jail, so I can do radical 4. Now look, 4 is perfect. So this actually turns into the square root of 10 all over 2. We're done because 10 cannot be divided by anything here, and now the radical's gone from the bottom. So when we have a radical with a fraction, we're always going to multiply by something and make the radical go away. So I'm going to do something very, very similar in number 2. Number 2, I have 3 over 7 plus radical 2. This first step is already done. So that means I have to do something with this, a radical on the bottom. This is a hard conjugate because of the plus sign right here. That makes it hard. The rule is change the sign in the middle. If I have a plus sign, I'm going to choose to write a minus sign. If I have a minus sign, I'm going to choose to write a plus sign. Since I have a plus sign, I'm going to multiply, remember. So this is called a conjugate box. Whenever you want the radical away, you always make this conjugate box, and remember it has to equal 1. So it's a fraction. I literally look at this and I write it exactly the same, except I put a minus sign there. They have to be different signs. Now, I copy and paste that to the top because the top and bottom has to equal 1. So the top and bottom must match. That's what makes it equal 1. So once this happens, now I have a new problem. Looks like this: 3, and then because when you multiply fractions, you multiply the top across, you multiply the bottom across. So look, there's my conjugate box. Here's the original. Now I'm just going to multiply. So I take the top, it's going to turn into 21 minus, look, 3 is not in jail, 2 is in jail, they cannot be put together, so it's just going to become 3 radical 2. The bottom I'm going to FOIL. So I'm going to FOIL. 7 goes to 7, that's 49. 7 goes to minus radical 2, that's minus 7 radical 2. Radical 2 goes to 7, that's plus 7 radical 2. Radical 2 goes to minus radical 2, that's minus radical 4. Look, this should always happen right here. They cancel out. If that doesn't happen, you did something wrong. The whole reason we choose this, the whole reason that we choose conjugates, the whole reason conjugates exist is to make the radical go away. So if that doesn't happen, we made a mistake somewhere. So look, those ones canceled. Look, this actually is 2. So this becomes, the top is still that, but the bottom becomes 49, and this guy right here becomes minus 2. So we end up with 21 minus 3 radical 2 all over 47. Now, I personally will accept it looking just like this. Some people will make you write it separately. Will make you turn it into 21 over 47 minus 3 radical 2 over 47. Either or. Either one's fine with me. So that's it for this Firestarter. Alright, I'm not going to go through the perfect squares again just to save you guys a bunch of time. So we're going to start with the bottom 3. So I'm going to start with the bottom 3. Alright, we're going to do those ones first, and then we're going to do the top 2 second. Alright, remember, we are not allowed to have decimals in our answer. If you have decimals in your answer, I'm going to give you 0 points. Alright, so I'm going to start with the, like I said, I'm going to start with the top 3. I'm going to look for perfect squares, and that's, so there are 2 rules when it comes down to breaking down radicals. So 2 rules for simplifying radicals. The first rule: no perfect square factors. All right. So when there's no perfect square factors, that's when I'm going to use this list of numbers up here. All right. So this list is going to help me with that rule. The second rule is no radical in the bottom, right, of a fraction. And that's when I'm going to use the conjugates. Right, conjugates are going to help me there. So, to start this real quick, like I said, I'm going to do these top 3 first. 175. 175 is not on my list. So 175 would be right here. So I start checking decimal, 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 decimal. What I mean by decimal is I do 175 divided by that number in my calculator until it doesn't give me a decimal. I end up with 7 times 25. 25 is perfect. Remember, perfect guys have to change to leave jail. So 25 gets to leave jail. He must change into 5. Remember, this is the human brain step. If you want to get credit, you must show me that step. 7, he's a murderer. He's going to stay in jail forever. So that's my answer right there. 5 radical 7. Done. 891, not on the list. Now, your list can go on forever and ever and ever, so you would double check and make sure, like when I take the square root of 891, to make sure it's not a perfect square, I put my calculator, it gives me a decimal. So remember, but I'm not allowed to write down the decimal. You can use your calculator to help you, but you just can't write down decimals only. So I start dividing. I do 891 divided by 400, decimal, 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 decimal. Keep on going. I end up with 81. So 891 becomes 11 times 81. 81 is perfect. Remember, perfect. So he's got to change. So this 81 right here changes into 9 outside of the jail. Because if he doesn't change, he's going to stay in jail forever. Now it's 9 radical 11. Square root of 324. Look, 324 is on my list. So look, 324, he immediately changes into 18 squared. Because he's got the little 2, he gets to leave jail. And like I said, we're going to talk a little bit later about why plus or minus shows up. because there are two options actually. Alright, now we're going to finish this. Like I said, I'm going to do this one first. So I'm going to do the second one first. So the first thing I do is because I don't want to deal with fractions inside the radical, I take the radical to the top and the bottom. So step one is I'm going to use the property for division. I'm going to make it radical 17 over radical 12. Now, since 12 can be broken down, I'm actually going to break it down first. So before I do anything with conjugates, I'm going to use 4 because 12 is 4 times 3. So I always look for rule number 1 first, even if I'm using fractions and stuff like that. So really, remember, 4 is perfect. He's going to turn into 2. 3 is a murderer. He's going to stay in jail forever. And I didn't do anything with the top. Now, if radical 3 was on the top, I'd be done because I'm allowed to have radical on the top, but it's not allowed to have radical on the bottom. So this is where we use our conjugates. So I'm going to say the square root of 17 over 2 radical 3. This is where I have to use my conjugates. This is an easy conjugate. Because there's no plus or minus right here. If it's easy, we just take the radical and we write it again. Now remember, because we're using conjugates, I call this the conjugate box. It always has to equal 1. Because it's easy, I just take radical 3 and I write it again. Now to make sure it equals 1, I just take radical 3 and I write it on top. Because now the top and bottom they match. Next thing I'm going to do is I'm going to multiply across the top. Remember, 17 and 3 are both in jail. So I can multiply 17 and 3 together. I end up with radical 51. The bottom, radical 3 and 3 are in jail. And eventually when you do this more often, you're going to know right away it's 3. But it's going to be 2 times radical 9. Square root of 9 is 3, so this bottom becomes 2 times 3, so that turns into 3. So my best answer for this one is radical 51 all over 6. Now you should double check and make sure there's not a number on this list that goes into 51, and there is not, so I know I'm done. So that's your best answer. Now, this first one, this one right here, because of this plus sign, hard. If it's hard, we always change the sign. So all I do, right, I'm going to rewrite this negative 1. I'm not equaling it. I'm going to multiply. Remember, that's I call it the conjugate box. Whatever's in this box, the top and bottom have to match. So this is how we change something without changing the value. This is how we make it look different without changing the value. So I just take this right here. I rewrite it. But I make that plus sign a minus sign. So look, I change the signs. I take that and I write it on top because the top and bottom have to match. That's what makes it equal 1. I can multiply anything by 1 and not change it. So this becomes negative 1 next to 9 minus radical 7. This becomes 9 plus radical 7 in parentheses next to 9 minus radical 7 in parentheses. So now I distribute on top. And on the bottom I'm going to FOIL. So 9 goes to 9. And guys, there is a shortcut. You just do a squared minus b and it will actually be your shortcut. But just in case you don't know what that means, is I'm going to just FOIL. 89 goes to 9, 81. 9 is in jail. Radical 7 is not in jail. It's a minus sign, so it's minus 9 radical 7. Notice 9 and radical 7 cannot mix and match because one is in jail and one is not in jail. Look, 9 and radical 7, they are not the same. One's in jail, one's out of jail. Now look, radical 7 and radical 7, it's minus sign because it's a plus and a minus. It's radical 49 because 7 and 7 are both in jail. This should happen every time. Those cancel in the middle. This guy turns into minus 7. So I end up with 81 minus 7 is 74. So I have negative 9 plus radical 7 all over 74. That's done unless you want to split it, which you could do. Some people split it, some people don't. Both of those are correct answers. So that's a lot of work, guys. That's why I didn't do this in class, because the conjugates is the hardest part, and we'll go over that a lot more in the next week.